A polynomial is a multi-termed expression. Poly means multiple, nomial means term. There are different types of polynomials. The first type of polynomial is a constant. A constant is just a number with no x variable. The equation for a constant is y equals a number. And I'm just going to put a for that number. The graph of a constant will be a horizontal line. A linear polynomial has an x term in it, and that x will be to the first power. But we're not going to write a 1 there, we're just going to say x. And there's going to be a number times x plus another number. Now you've seen an equation that looks like this before, slope-intercept, y equals mx plus b. If we think of a as our slope and b as our y-intercept, this is the equation of a linear polynomial. The graph of a linear polynomial will either be negative or positive. A quadratic polynomial, the highest power of x will be squared. We just got done studying quadratic polynomials, and the equation of a quadratic polynomial in standard form is ax squared plus bx plus c, where we have a number times x squared plus a number times x plus a constant. The graph of a quadratic polynomial will be a parabola, either opening up or down. A cubic polynomial, the highest power of x will be 3. The graph of a cubic polynomial will look like this or like this. It's kind of like a parabola that bends one more time. It's like a parabola and a parabola, a parabola and a parabola. A quartic polynomial has an x to the 4th power in it. The graph of a quartic polynomial will be kind of a W-shaped thing. It's like a parabola and a parabola and a parabola. And it's either going to open up or open down. If you look, the highest degree of x in each one of these cases tells us what kind of polynomial we have. So if we look at a quartic, we have x to the 4th power. Cubic, we have x to the 3rd power. Quadratic, x squared. Linear, x to the 1st power, but we don't actually write that 1 when we write our equation. And our constant, we actually have x to the 0 power. And if you remember, x to the 0 power is just 1. That's how we get this constant term. Now, quartic is not the highest power of x. We can keep going. In fact, the polynomials keep going on for infinity. In example 1, we have to decide if the function is a polynomial. To decide if a function is a polynomial, all the powers have to be integers and positive. If we look at our first problem, if I were to write this in standard form, where my degrees go in descending order, I'm going to have pi x squared plus 1. In this problem, I don't have an x to the first term. I just have my ax squared plus c. I have pi x squared plus 1. So is this a polynomial? Yes, it is. The highest degree of x is 2, which means that it is quadratic, and my leading coefficient is the number in front of my highest degreed x. So in this case, my leading coefficient is pi. In example 2, if I were to rewrite this, I would have 3x squared plus, this is really x to the negative first power. When I have x in the denominator of a fraction, I can bring it up top to make it not in a fraction. And it makes my degree negative, which means that my power is negative, which means that this is not a polynomial. If I look at the last example, 2x to the first power, that's all right, plus x to the 1/2 power. 1/2 is a rational number, but it is not an integer. So this is not a polynomial. To add and subtract polynomials, add or subtract like terms. What makes like terms? Well, you have to look at the base and the power. Both the base and the power have to be the same to create like terms. So if I look at this first problem, I have a cubic polynomial, because my highest power is 3, minus a quadratic polynomial, because my highest power is 2. Now, in order to subtract these polynomials, I need to subtract my like terms. Now, if you look, I'm subtracting this entire polynomial. So this subtraction sign gets distributed into the parentheses, because I'm not just subtracting this x squared, I'm also subtracting the negative 2x, and I'm subtracting the 1. So I do distribute this subtraction into the parentheses. So I'm going to have to subtract the like terms. I have a x cubed here, and I'm going to subtract my x cubed from this polynomial. But I don't have any. So I just have x cubed minus 0x cubed. That gives me 1x cubed. Now I need to subtract my x squareds. Well, I have no x squareds in my first polynomial, so I have 0x squared minus x squared. 0x squared minus x squared gives me negative 1x squared. Now I'm going to move on to my x to the first powers. 3x is my x to the first power. I have 3 of them, and I'm going to subtract negative 2x to the first power. So 3x minus negative 2x gives me positive 5x. And the last, I'm going to subtract my constant terms, my x to the 0 terms. I have negative 4 minus 1, which gives me negative 5. I'm done because I have all my like terms combined. So subtracting a cubic minus a quadratic gives me a cubic answer. To multiply polynomials, I need to distribute and then simplify. to multiply polynomials, you've already done that when you use the FOIL method. Well, the FOIL method is really just the distributive property, an acronym to help you remember the distributive property. But if you remember to multiply polynomials by just distributing every term to every other term, you don't need to worry about memorizing FOIL, you just need to distribute. So I'm going to take this 2x term and I'm going to multiply by every term in my second polynomial. So 2x times x squared gives me 2x cubed. 2x times 2x gives me 4x positive. 2x times negative 5 gives me negative 10x. Now I need to take this second term, negative 3, and multiply every term in my second polynomial. Negative 3 times x squared gives me negative 3x squared. Negative 3 times 2x gives me negative 6x. Negative 3 times negative 5 gives me positive 15. So I've distributed. Now I need to simplify. I need to combine my like terms. Notice that after I've multiplied, my parentheses disappear. So I need to combine all my x cubes. Well, I have 2 x cubes. This 4x should actually be 2x times 2x, which should be 4x squared. So I need to combine my x squared terms. 4x squared minus 3x squared gives me positive 1x squared. My x terms, my x to the first terms, negative 10 minus 6 gives me negative 16x, plus my constant terms, 15. So if you look at the original, I had a linear polynomial times a quadratic polynomial, and my answer is cubic. And the last problem, I have a linear polynomial times a linear polynomial times a linear polynomial. And to do this, I'm going to distribute and then simplify. But before that, I want to show you another problem. 2 times 3 times 4. To multiply 2 times 3 times 4, I just take 2 times 3, and then I take that answer times 4. I don't distribute 2 times 3 and 2 times 4. I don't have a grouping symbol, I don't have addition, so I'm not going to distribute this 2 to everything into to the 3 and to the 4. I'm just going to take 2 times 3, take that answer, times 4. I'm going to do the same thing here. To distribute, I'm going to distribute this x and this 1, but I'm only going to distribute the x and the 1 to what's directly behind it. I'm just going to multiply these first 2 polynomials first, and then whatever that answer is, I'm going to multiply it by x minus 3. So I'm going to take x times x and x times 2. And 1 times x and 1 times 2. And I'm going to put parentheses around that because I want to make sure that I take this whole polynomial times this whole polynomial. I'm going to simplify. I get x squared plus 3x plus 2 times x minus 3. So x plus 1 times x plus 2 is x squared plus 3x plus 2. Kind of like 2 times 3 is 6. Once I get this answer, then I'm going to take this polynomial times this polynomial. X squared times x squared times negative 3, 3x times x, 3x times negative 3, 2 times x, 2 times negative 3. So I've taken every term in this polynomial and distributed it to every term in this polynomial. Now I need to combine my like terms. Combine my x cubes, and my x squareds actually cancel out, so I don't need to write those down. Minus 9x plus 2x gives me negative 7x minus 6. I started with a linear times a linear times a linear, and my answer is cubic.